switching. Okay, okay. ఏది ఇది నాకు తెలియదు.
Forward, backwards.
Okay, okay. Good afternoon, my dear faculty members. At the outset, I am thankful to the Vijay Krishna sir HOD for giving this opportunity. As you, madam, introduced me that I am started my career in 2001 actually, but after completion of my training, I started my career in 2002. I did my BTech from SRK Engineering College, Andhra University. It is affiliated to Andhra University. Actually, I would like to know that how many have you experienced the landline technology? Okay, thank you. And how many directly that experience is like automatic, or you are taking any assistance? Assistance means when you lift the phone, you dial the number, automatically it is connected to the other person. It is not happening in the earlier days. Earlier days, you have to take assistance of the operator. Like when you lift the phone, it sends the signals to the operator. He has to ask you where you want to go, which number you are going to connect, or where you want to go to connect the customer. That is totally BSNL started the communication in 1970, 80. After revolution of digital revolution, we completely come to the automatic dialing facility, that like automatic connectivity. Now in that one, earlier have you had broad any experience how this, at least now I would like to tell, before getting to the wireless networks, I would like to know how many have experienced this landline technology. That is public PSTN network, we will call public switch telecom network, PSTN network, telecommunication. That how it will be looks like in practical, because you people are more theoretical experts, I am practical person. That's the reason I am taking that. How many have a idea how the landline connectivity taking place? Basically, like let me take this like Rajahmundry, let me take Rajahmundry, Samarla, Vijay, Kakinada, and so many talukas are there. How it will be connected to other stations, like a person in US, a person in Guntur, a person in Hyderabad, how it has taken place? All the landline customers, landline subscriber like customers are connected to the nearest telephone exchange. That is like I will show one diagram how it will be. Sir, can I have a pen? See, this is a connect. See, this is a one kind of architecture, how it will be there. This is the landlines where it is connected to nearest our like Rajahmundry, like any taluka centers, one telephone exchange will be there. All are connected to this telephone exchange. From this telephone exchange, all are connected to district headquarters, where it is a district, suppose if in Guntur, it is a Guntur district headquarters. All the talukas are connected to Guntur district headquarters. In Rajahmundry, not is Kakinada, in Rajahmundry is the district headquarters for our telecommunication. All located exchanges are connected to Rajahmundry. It is again, it is connected to AP, our state headquarters. Again, state headquarters and this Tamil Nadu or other states are connected to that is called as MPLS cloud, all state to state connectivity. Here in all headquarters, like in all headquarters are connected to one central main. This district headquarters will have a central main switching center. All switching centers are connected to here. These all are interconnected. Like that, here now we can see the optical fiber. Earlier we have analog communication, like most of the highways you can see the big towers, almost 100 meters towers are there. Earlier days in the 1970s we have wireless communication, that is using analog communication. Most of you might know that analog communication. Analog communication, all are connected to that. After that analog, when it come into the evolution of digital revolution, digital technology, digital communication, optical fiber communication has taken over. This optical fiber communication, all OFC cables, most of the people have seen on roadways, you can see the duct, green color, red color, ducts will be there in that OFC cable. Each OFC cable can carry unlimited bandwidth. We can provide unlimited bandwidth. Like that, it will be interconnected, will be there here in the all the digital switching taking place. Now we can see that how the wireless communication started. In this diagram, everything is same. In wireless communication setup also is same, but where this wireless taking place. Now we are seeing this like a mobile technology, where this wireless fit into in this diagram. Can I have idea of that? Where this wireless communication fit into? Okay. Let us have interaction. Where this wireless fit into that what? Actually, nowadays we are having, instead of landline, we are fitted with, we are with mobile. Without mobile, nothing is there as of now today. Where this mobile will come? Now landline is totally outdated. We don't have a landline. Now landline between sir told that actually one, instead of exchange, we are having a wireless communication setup, that's transmitter and receiver. Where this transmitter and receiver is our mobile, transmitter, at both it will work as a both transmitter and receiver. At the same time, another tower will be there. That tower will serve as a, between the tower and our mobile device, we have a wireless. Remaining everything is connected only. Everything that we can see the architecture, this architecture between the what we call as a antenna. Now we can see antenna. From that antenna to mobile device is the wireless communication. Remaining part of the connectivity is established with optical fiber communication. That is like we can get into the one by one structure, how the architecture will be taking place. That is the physical idea of how the telecommunication will happen in the practical way. Like in let me give more elaborate on that one. Like Rajahmundry, physical in BSNL, how the Rajahmundry, all talukas are interconnected to the Rajahmundry digital transmission center. All the mobile community, mobile equipment, at the same time lease line, we are providing lease line equipment, banks, and almost in state government offices. All offices are located in Rajahmundry are passing through the digital transmission center. It is where digital transmission center to other districts, it is connected with routers. You might have seen that routers. Have you heard of that routers? Like that back-end interconnectivity will taking place. That is the, now we will see the wireless communication. Shannon-Hartley theorem. Most of the wireless communication people might be know that one, who is dealing this subject. What it is? Main that wireless communication started with this, based on this principle, theorem, Shannon-Hartley theorem. That theorem says whatever the channel we will have, that capacity is equal to the spectrum width. Spectrum is the, for one technology we will have one kind of spectrum, like one slice. In frequency we can say one slice. That spectrum into log, actually antenna is just, I have, because now we are speaking about the 4G, 5G, 3G technology, that antenna plays a vital role for evolution of technology from 3G to 4G, 4G to 5G. That antenna plays a vital role. W2 into log 2 1 plus signal to noise ratio, where exactly when we are into the near to the transmitter, we will have a good experience with as well as quality of voice quality, at the same time data speed also we used to have good quality. When we are moving to far to the antenna, we have that transmitter, the signal to noise ratio becomes weak. Due to that, when we are far moving away from the tower, our channel capacity will, and the quality of the radio channel will decrease. Actually, let us have a history where this just a few, where first in 1896, Marconi has established a wireless communication for radius of 3 kilometers. 3 kilometers using Morse code. He has started the original wireless concept. Started in 1896. In 1946, in US, AT&T Labs, Bell Labs has started the wireless communication deployment. Initially, they have started using the frequency modulation. Like earlier, we used to have a radio. A radio is nothing but frequency modulation. FM techniques, based on the FM techniques. Like that, in 1946, they have started the concept of wireless deployment, where the tower is used, tower is located at a hill area, almost hill area, they have to install the tower, and that receiver is with car, it is in have car, that receiver will be in car, that is like that, whenever the car is moving to the near to the tower, they have to have establish the communication. Behind that, after tower is connected to the nearest PSTN network on wired. That here that whatever the tower in initial days, they have started the tower. Actually, in car mounted receiver, where that car mounted receiver used to receive the signal, but it could not able to the uplink, it could not able to connect to the receiver, transmitter. Whenever it is able to receive the signal, that car mounted receiver, it able to receive the signal, but it could not able to send the signal. In that time, they have started with the concept that earlier that hill area tower, it almost serves around, that is totally narrow band. It serves almost 20 miles, that is almost 36 kilometers radius it is able to serve. But what they have faced a difficulty in initial days, they could able to receive the communication from tower, but from car they are unable to send the signal to the tower. In that scenario, they have started installing for uplink communication, they have to install so many towers connecting to the for uplink connectivity on the roadside, on the it is connected path. They used to deploy 3-4 towers for exclusively for uplink communication. Like that, what is the tower serving area we will call as a mobile service area. Initial days that AT&T Labs started their communication with 30 kHz channel bandwidth with 3 channels. Later they have developed 10 channels, almost they have started communication with 33 channels. With that 33 channels, they could able to establish the wireless communication. It is in 1946 and 50s, yes, they have developed the AT&T Bell Labs. This is not the 1G technology. It is like we can say it is a starting of wireless communication. The concept conceived to have a wireless communication in 1946 onwards. They have done so much of research. With that, now we got the real deployment of first generation technology in 1970s onwards. They have started deploying first generation mobile communication. That is from 1G on 1980 onwards, we have started the first generation mobile communication. First mobile, most of them know that cordless telephone we used to have in our landline technology, where we have to have cordless telephone. In home itself, we can speak wherever we are freely, we can move in the house and talk to like that. First, Motorola has manufactured the mobile handset, first generation mobile handset, which is a very bulky. How much it will be there, bulky it is. First cellular network started in 1978 Bahrain. Now we can see the first how the generations evolution taken place from first generation to fifth generation. But in India, first generation we have not seen, second generation mobile only concept is deployed in our India. First generation mobile started in 1980s. 1980s they have started the first mobile communication, wireless mobile. They used that in US developed a AMPS technology, and NOIDA countries like Denmark, Norway, Sweden, Finland, they have started a NOIDA mobile telephony and total access communication system developed by Japan and UK. These countries started the first generation mobile communication in 1980s, and only they could able to provide only voice calls. Only voice calls they used to provide in the 1980s. When after 1980s they have started that mobility also is very less. We don't have a good mobility. After 10 years, 1990, we have started the digital communication taken place. That is, we could able to provide. We can say 1919 is a digital revolution for our telecom. In 1990s, we can provide only second generation mobile communication taken place in 1990. In 1995, in India, first Airtel deployed the that Airtel deployed the 1995 Airtel deployed the first second generation mobile communication in India at first Delhi, but BSNL started its communication in 2002, second generation in Lucknow. Second generation mobile communication is the world most accepted technology, that is called GSM, Global Mobile System for Mobile Communication, which is nowadays most successful technology. We can say foundation technology is the second generation technology. That is exactly nowadays even BSNL is providing the services using the 2G technology. Now I would like to ask, name any one or two companies which developed this first generation and second generation equipment. Motorola. Okay. Next. Huh? Reliance is service provider, sir. It is not a CDMA is a Qualcomm manufactured. CDMA is Qualcomm started manufacturing the CDMA. And who generate first these companies behind the first generation, second generation mobile equipment? Madam? BlackBerry is the phone, madam. Handset like what we can say Samsung, like that. Nokia is one of the handset manufacturer, at the same time mobile equipment manufacturer also. Nokia, Siemens, Motorola, Huawei and AT&T Bell Labs. These are the main vendors contributed for the development of mobile communication. Where this second generation GSM is in that one we have a IS-95 also, that is CDMA technology, code division multiple access technology. In these are the technologies. Most successful technology is the GSM technology. Third generation technology, in the second generation also we have experienced the data also. Sir, anyone have used in 1990s mobile handset? Any have an experience? Nokia 3310 phone, experienced, where you get any data experience is there in that one? No, na? Actually in that one 2G initially we don't have services for data in 2G second generation mobile communication. In second generation we can say 2.5G, which is the GPRS, which started providing the data communication with the initial speed of 20 kbps. That is packet switching, that IP, TCP IP concept, that IP concepts started in the second 90s with the evolution of in digital communication. You can have seen that TDMA, PCM technology, when it is started. Sir? No, sir. In 1990s itself started because of that digital revolution. So much advancement in the communication technology has taken place. In 1990s, that is the main, now we can see so much drastic change in our mobile communication, totally communication itself, not only mobile communication. So many, in communication sector itself, we can see the major foundation for revolution is started in 1990s with the advancement of digital techniques. Second, the 2.5G, where we can get at least only 20 kbps, where so much of it, at least we could able to even cannot open the mail also, at least that time. 2.75G, that is edge technology, that is GPRS, general packet radio switching. For that, in second generation itself, we have small software upgrade and certain components, introduction of certain components. We could experience the data in second generation itself, 2.5G. In edge technology, 2.75G, we could have 200, almost 200 kbps, means we could able to send any images like that. Third generation communication mobile is totally shifted our our life from analog to beyond the mobile communication. Earlier we used to mobile only for voice only. In second generation we could able to send messages like short service messages we could able to send in second generation. Third generation total revolution started. It started in earlier days we could able to send in 90s we could able to hardly we can send mail and messenger services like very few. In 2000 that second generation mobile communication started taking place which changed our life, started for our life towards digital environment. Second generation we could able to get internet like we can mobile itself we could able to browse internet and we can get any information on mobile itself. There we can have 3G we can have started the smartphones. Like I can't say that is smartphone. Camera enabled phones came into the, we can see in the third generation after 2000 onwards that mobile handset used to have camera. With that one we could able to send and receive messages like multimedia services like any picture messages we could able to send and receive, we could able to send mails, we could able to browse the internet for any information. In 2000 third generation technologies are WCDMA technology and that is wide band code division multiple access. That another one is HSPA, high speed packet access and high speed packet access plus, and EVDO, that is CDMA technology, CDMA 2000, and EVDO is the CDMA based technologies. Fourth generation communication technology fourth generation started in 2010. In third generation in India almost started in 2006 and 7 onwards. In 2010 onwards fourth generation revolution we can see in the world. Main technology is LTE, long-term evolution advanced, and gigabit LTE. Now I cannot say anything because you people are experiencing what are the technology in mobile. Everything we could able to do whatever we want to do on like laptop and computer, and everything happening on mobile. Nowadays without mobile we are unable to do anything. Like that it's became a part and parcel of our life with the fourth generation revolution in mobile technology. And CDMA, and one more thing is there, WiMAX 16G version, that is also the fourth generation mobile technology, but successful technology is LTE. Now fifth generation is totally different. Up to fourth generation our user equipment is we are having a communication only with, up to fourth generation we have what is mobile communication is with up to fourth generation we have a communication only with sir man to man. Okay, that is good. Another one, we have communication with, it is part and parcel of our life. Without handset, up to fourth generation, the mobile communication technology is with only mobile only. Mobile to mobile communication, that is with human interface. Only mobile up to fourth generation, it is the technology is with mobile only, mobile handset, mobile communication. Fifth generation is different. Fifth generation is called fifth generation technology, that is 5G new radio. That is fifth generation, somewhat change taken place. In the fifth generation communication, some change is there in our lives. Along with mobile, we used to communicate with devices also, machines. Even with devices, like nowadays in our country we are speaking about smart cities. With fifth generation, speed automatically I could able to say, third generation we could able to get speed in mobile handset up to, in WCDMA we used to get up to 14.4 Mbps download and 384 kbps upload. With the evolution of in the third generation itself, somewhat evolutions taken place. With that utmost HSPA we could able to get 28.7 kbps speed download and 7.7 Mbps in upload. In the fourth generation we could able to get almost ideal condition 1 Gbps. Ideal condition 1 Gbps, but in practical experiences mostly we will get hardly 20, 30, 40 Mbps. But user experience means whenever we are in worst condition, in where we can get maximum 10 Mbps. In fifth generation, that advancement of fifth generation technology, where the speed is almost 100 Gbps and user experience is 10 Gbps, but that much we are not getting, almost in 100 Mbps, 50 Mbps to 100 Mbps we are getting in fifth generation as practical experience in India with Jio or Airtel. BSNL not yet started 4G, 5G services in India. That is started in the sixth generation mobile communication technology. So actually you people are seeing that carrier modulation techniques on 6G violation. So what is 6G? What is 6G? Have you heard about Elon Musk? What is 6G? He is making so much, he is totally changing the world in communication, Elon Musk. What is 6G? 6G is totally nothing but 6G where we want to connect everything. Nothing is left with unconnected. In sixth generation, we want, that is the idea of International Telecom Union is to connect and everything with everything to be connected on communication network. Whatever it is, man or machine or industry, everything. Actually, that smart cities concept started in fifth generation, like so much smart grids. Now in homes itself, in our daily home itself, we can see the refrigerator. We can sit in our office. We can control our AC, which is located in our home. Even refrigerator, how it is happening? IoT is backbone, that is fine, sir. But how it is, how IoT is taking place, how the IoT communication is taking place? Sir? Protocol is completely, that is definitely it will be there, sir. Without protocols we are nothing. That because of fifth generation communication, where devices are started communicating with internet, that with maybe internet, we can say. In house itself, it is to be connected with Wi-Fi. In office, it should be connected with Wi-Fi or mobile data, 3G or 5G, 4G, like that it will be connected, and home also it should be connected. Even in, like that, even now driverless cars, driverless car with 5th generation only. Now let us, for all these generations, what is the driving technology? What is the driving technology for first generation, second generation, third generation, fourth generation, fifth generation, and sixth generation? What is the driving factor for that? Driving technology. VLSI, who is dealing, sir? VLSI is the main technology for the revolution of 1G, 2G, 3G, 4G, 5G, and 6G also. Where VLSI, what its main? Why we are talking about VLSI? That is correct, sir. What is the background for that? Now, earlier we used to have a TV, big TV, almost after that smart TV. Now it is TV, very smart TV now, LED TV, after that smart TV. What is the, how this evolution taken place? Pardon, sir? Okay, that is also good. That is the part, how that size come down. What is the drive? What are the technology changes for that? Yes, that is IC technology only. Exactly. VLSI is the integration of thousands of millions of transistors on a chip. Actually, in that, madam? Madam? Channel? Actually, this VLSI, actually that one Gordon Murray, mostly who is taking with that one, what he has done is he stated one theorem. Every 2 years, the transistors on the chip getting doubled. Of course, that is in the 90s he used to say that. Nowadays, thousands of millions of transistors are coming to the embedded in the processors. In processors itself, because of this processor advancement and memory advancement, so this much communication we could be able to achieve. That is the main processors. Earlier processors used to have this much hardware. Hardware is a bulky hardware we used to have. After the couple of years of in this evolution in VLSI technology, that miniature is come down, that size will come down, that processor. In one IC, we can have so much of processing speed we could have, and small. Now, Chandrababu Naidu Garu is telling that quantum computing, edge computing, we earlier seen quantum computing. That in processor itself, the speed of the processing becomes very faster, much high speed. With that, we can have completely, the VLSI changed our main communication technology from first generation to sixth generation. Now I get into the first generation mobile communication technology, that is analog communication. Analog communication means completely analog, that is frequency, like a radio. Radio we used to have only receiving, but we could not able to send that one. Here communication, first generation mobile communication taken place in with the channel bandwidth, that is spectrum width, it's the 30 kilohertz. But that is technology what we are using is frequency division multiple access. Suppose we have 30 channels, 30 kilohertz channels, 30, in that frequency we can accommodate only 30 customers. With that 30, between 30 kilohertz, where we will have a small guard band, after that like that we can have. But in first generation mobile communication technology, we used to have the cellular concept, because the cellular concept hexagonal, that cell is hexagonal shape, it will be a cellular concept first started in first generation mobile communication technology, and frequency reuse also started in first generation technology. With that maximum speed, that channel capacity is 30 kilohertz is the spectrum width. Maximum, it started in a narrow band, 800 megahertz to 900 megahertz. That is modulation technique is frequency modulation technique deployed for first generation mobile communication, where we can have only analog voice is the, but in the whatever the frequency reuse means, suppose 30 kilohertz channel, that A is the 30 kilohertz channel, we are using in that green area is called cell. Cell is coverage, small geographical area covered by the BTS. That 30 kilohertz channel, after spacing some channels, we are used the B channel also. That is the frequency reuse in frequency reusing of for mobile communication started in the first generation mobile communication technology. That is the first generation mobile handset, that is the Motorola handset. Main in 1919, but speed, that 2.4 kbps speed, first generation we used to only for voice communication itself, we have used that APMPS, that is US based technology, NMT is Denmark and technology, TCS UK based total access communication technology, but its first generation features, what we can say, only voice we used to provide, but limited users, maximum we can accommodate 30 customers can speak at a time. Beyond, for anyone after 31st and 31 person want to have a call, but he used to get busy. Because of limited users it will be there. No encryption, encryption means security will not be there, because anybody want to, between the BTS to our mobile, anybody with trans receiver concept, hardware we can put and we can tap the, with the frequency modulation we can tap their conversation and we can hear that, because there is no encryption and security in that one. Cellular coverage, first geographical, but device itself very bulky, we hardly we can get 1 hour, 2 hours, after that we have to put the charging. That is the first generation mobile technology. Second generation started in 1990s. Technology is digital, complete digital technology. That is we can say PCM concepts, TDMA concept. That is GSM is a global, in that one, in Bell Labs started a digital communication, that is DAMPS is the Bell Labs technology. GSM is the European, ITSI, European Telecommunication Standard Institute will be there. They have developed the GSM. CDMA technology is there. In that one, GSM is the globally accepted high standard technology. That is European technology. They have, because speed up to we can get 64 kbps. 64 kbps generally it is a, in digitalization 64 kbps is the voice for voice one analog, that is 64 kbps is the bandwidth is for accommodating one voice. Mostly GMSK modulation technique is in first generation we have FDMA technology, in GSM we have GMSK technology, and multiple access, time division multiple access is the access technology we have, and bandwidth is more bandwidth, that is from first generation or channel bandwidth is 30 kHz. In second generation 200 kHz is the channel bandwidth we have. Let us see the architecture. This is the mobile. We used to have that wireless communication is the interface is BTS. BTS is so many towers now we are seeing in BTS is the towers where we can see in our area so many towers we can see, that is BTS. BTSs are connected to the base station controller, which is the BSC is the main controller for BTSs and line radio resources. Again BSC is connected to MSC, main switching center. Again main switching center is connected to GMSC, certain network elements, that is HLR, VLR, authentication center, home location register, VLR, visiting location register, and PSTN is our landline connectivity network. Here actually physically how in practically how the BTSs are. For MSC, suppose in our Rajahmundry itself, certain BTSs are connected to BSC. One area will have one BSC and all BSCs are connected to MSC. 3-4 districts are connected to one MSC. GMSC is the almost for a state we can have only one or two GMSCs. In one GMSC is in Guntur, another is in Visakhapatnam, another one is Tirupati in BSNL. HLR is located in Hyderabad. VLR also authentication center. That is the main network elements needed for mobile authentication and for our complete database of mobile subscribers. In SIM, we can, most of the people know that SIM and device second generation. That is the second generation mobile Nokia 3310, from where we can second generation mobile handset, that is. This is the network architecture looking to that. PSTN is our landline network connectivity. This is the radio network architecture looks like in second generation. Now we can see the features. Voice, in second generation we could able to do voice calls. At the same time we can able to send the messages also, SMSs. Security, digital signals, we have a encryption over the radio path, what are the signals we are sending and receiving. And network efficiency, more efficient because of this TDMA technology and frequency reuse concept. The network efficiently we can manage the network, and devices, that is small phones, and more battery life. And the second generation, actually that radio signals power consumption is somewhat more improved from first generation. For charging that handset, we could able to almost half of the day it has to come. In fact, that major one of the best feature in the GSM technology is we have a handset. That handset wherever we go, that is mobility. Best feature in the second generation technology is mobility. Wherever we go in the world, just by changing the SIM, we can get the mobile we can have a mobile communication. In second generation itself, in our India, in 1995, we started the second generation mobile communication, and at the CDMA based Reliance, that is Reliance started that is a bundled SIM. That SIM is not physically, we don't have the SIM, but it is bundled with the handset. That second generation started by mobile, Reliance started the second generation mobile communication technology. We can say because of this main successful and most technology is the GSM technology only. Next we can see the digital voice, spectrum, mobility, SMS. And the second here, I would like to tell that 2.5G generation mobile, 2.5G generation mobile communication, we could able to access 20 kbps only, hardly it is 40 and 170. How it is taken place? How the data communication data started in second generation? That architecture will be like that only, but additional component is introduced in that one, that is SGSN and GGSN, and GGSN is connected to packet data networks, PDN. What GGSN will do? That is that is a serving gateway support node, that is GPRS technology supporting component. We asked to we deployed a SGSN component, GGSN component. It is relevant to that. We have a software upgraded in the MSc and BSc also. With that one, we could able to get the data network. Same with Edge also like that, up to 384 kbps, we could able to get the. In second generation, that is the main GPRS component with the component of GPRS technology and GGSN components, we could able to access the data in the second generation. 2.5G, same GMSK technology we are used here. We can call packet switching. GPRS and 2.57G with the modulation, in the modulation technology change, that's in second generation itself, voice coder, VCoder, we can, you could have studied that VCoder, that 64 kbps voice channel is compressed to 8 kbps. With that 8 kbps, with so many 64 kbps occupies the more bandwidth, say 8 kbps will occupy the less bandwidth. In compressing and decompressing technology, we could efficiently use the radio resources. In this 2.75G also, we have started that sending voices and GPS based services also. Now let us take a break for 5 minutes. Thank you. Okay, now we will look into this third generation mobile communication, which is the completely internet era where we started using the internet in third generation mobile technology. That almost bandwidth is 5 megahertz. In first generation is 30 kilohertz, second generation is 200 kilohertz, third generation is 5 megahertz. 5 megahertz, the capacity of the carrier will be more. That is, with that one, actually ITU has given certain standards in third generation. Third generation onwards, the concept of one standard for world telecommunication has started. Third generation, that is technology is high speed packet access, HSPA and WCDMA. WCDMA we can call as UMTS also. That HSPA plus, based on the speed versions, the technology has been changed. ITU has given this that is 3GPP we will call, that is third generation partnership project, which is the consortium started for developing one standard technology for world mobile communication. This is the basic. In 2007 in India we have started the 3G third generation mobile communication in 2007. In that 2007 we can have so many service providers. You can see that Tata, Docomo, Idea, Hutch. Next, almost 10 companies we can see in MTS, BSNL. Reliance is not there that time, but Airtel. Almost 10 companies started providing 3G communication. From here onwards, we in third generation mobile communication in India we can have great future in sense of users. That is free incoming call, and tariff also 1 second, 1 paise 1 second. That is started in third generation mobile communication technology. Let us see the architecture, how the actually in this one we can have a 3GPP, we can say consortium, which is started developing one standard technology for world communication, that is GSM only. WCDMA, it is leveraged on GSM technology. 3GPP started giving releases. Release 99 is the starting release for 3G network. Here RAN, radio access network, and core network. Earlier we don't have separate segregation for that. Here SIM, we can have end user, we can have mobile, and that is the third generation supported SIM we used to have. Radio access network, where in third generation actually with the processors and physically, practically what we can see, what the difference we will make is, in second generation mobile, almost BTS cards will be like that, this much width will be there. One subrack almost can see some control cards will be there. Like that huge hardware, big hardware will be there. From that, now in the third generation mobile technology, that sophisticated hardware become very small, like this much will be there, one BTS. In that itself battery will be there. At the same time hardware almost 1/3 hardware size come down, and the radio power, the radio channels like our mobile to BTS, the power utilized by our handset and the transceiver power levels also so much advancement happen, less power with compact design and less power consumption. we could have a better radio resources and power energy efficiency we could achieve in the started in the third generation itself. In the third generation, that radio network we used to call BTS is called as node 1 and RNC. Instead of many BSCs like BSCs, RNC used to be there. One RNC will cater almost all the BSC, all BSCs are connected to one RNC. RNC, each district will have one RNC. Earlier BSCs, so many BSCs will be there. In suppose in East Godavari district, so many BSCs are there. All BSCs are connected to MSC. But in 3G, we will have RNCs are very limited. Instead of one or two RNCs will be there. All RNC, for that RNC, all BTSs are connected in that one. Here, this is called as a radio access network, where radio resources are managed. Radio access network, where radio resources means channel, how the transmission will takes place between mobile handset to BTS, that's a tower. At the same time, how the towers are managed, and all this from tower to our network, we used to connected with E1. E1 means 32 channel bandwidth. We used to connect that RNCs are connected again to MSC. Here we can have two domains will be there in core network. One is packet switch domain, another one is circuit switch domain. Can you, anyone can differentiate that? What is circuit switch and packet switch? What is circuit switching and what is packet switching? Exactly, sir, but in circuit switching also digital will be there, but what is main one basic difference is there in packet switching and circuit switching? Sir? Internet only, but I am internet only because IP based communication taken place with that IP based technology. That is totally IP is packet switching only. Here in circuit switching, what is circuits means? Actually store and forward communication takes place in packet switching, but circuit switching dedicated path will be established in digitally. Not completely analog, but digitally end to end one complete dedicated path will be there in circuit switching. Circuit switching again it is connected to for circuit switching it is connected to our for establishing voice landline, because that time so many landlines are more, mobiles are less. Because of having communication between mobile to landline customers, we used to connected to circuit switch. For data networks, it is connected to IP network. That is packet switch is connected to IP network. That HLR generally is one thing I would where this MSC, GMSC, VSLR, HLR authentication, where we can see this network elements physically. Physically, we can see these MSCs where we can suppose in East Godavari district headquarters will be there, MSC will be there. Remaining this HLR, authentication center, VLR, SMSC, all are for based on the volume of the traffic. We used to GMSC and MSCs are connected to, if certain districts have very less traffic, we used to club that one. For MSC, 3-4 districts are connected to one MSC. VLR, HLR for state it will be there, only one HLR will be there, one VLR will be there, and these are connected in, all are connected with fiber only. Because that aggregation equipment, like we can say transmission technologies, I can say like this, all this takes place with transmission technologies. Earlier we used to have DWDM, dense wave DWDM technology. With that one now we can have a next generation optical passive networks, that is OTN, optical transport network. With OTN, now currently we are using, for this highly reliable networks, we are using optical network, optical transport networks. Here that this IMS, anyone know that IMS? IMS, it can come in common networks. IP multimedia services, but the first initially in third generation we don't have this IMS voice over IP, voice over IP, voice over IP, that initially with IP technology, IMS, IP multimedia services. With the advancement in the third generation technologies, when we are able to have a greater speeds, almost 14 Mbps, 28 Mbps and 64 Mbps. Last, it for providing voice service through data, packet switch domain, providing voice services, we have a IMS, IP multimedia subsystem. This is the third generation technology. In third generation, we have features. Third generation features is the mobility. We can have mobility, greater mobility. At the same time, voice calling. At the same time, this mobile internet. From where we could, from mobile itself, we could able to send the mails, messengers, and multimedia, means sending messages, pictures. And in this mobile internet, where from mobile itself we could able to browse the internet for getting information. At the same time, video calling also started. Video calling is nothing, not what we are using in WhatsApp. WhatsApp video calling is different and 3G video calling is different. That is, we can say, is a native video calling. In 3G video calling, suppose I have a 3G phone, other end also should be have a same 3G phone, then only a video call can be established. That is the call started in video calling. And mobile data almost we can get almost 10 Mbps for even 63 Mbps. Started devices, smartphones. Earlier madam told that BlackBerry is the one of the unique feature of the third generation mobile handset. That is highest security you can have. That is 128-bit encryption will be there in that one. That means from BlackBerry phone to BlackBerry phone, what are the data we are sending on that one, it is a 128-bit encryption. That encryption initially used for having banking accounts. When we want to do the banking account, we used to have a 128-bit encryption will be used. That encryption, that smartphones means camera phones started in the third generation mobile. With that GPS services also started. GPS means wherever we are. Nowadays Google Maps came up with so much in that one technology. Earlier GPS services are started in the third generation. Industrial applications, you might have seen that area, this logistics, they used to use this one GPS based services, that is like ONGC tankers. You might have seen that ONGC tankers. Earlier we don't have the security to track the tanker, where it is going, how it is going, where it is moving. That logistics services, GPS based services, first deployed in 3G technology in Mumbai with Nokia navigation services. Like actually impact on the society, we can say shifted the mobile phones from voice to data. Our lives also started changing in 3G. Third generation mobile, our lives started. We became more addicted to the mobile. Earlier we used to only have the voice communication. For third generation onwards, we started adopting to mobile. Just we shifted our focus to mobile. In third generation itself, actually third generation, release 5 started, release 5, release 6, release 7, release 8, release 10, like that such an 3GPP has developed certain releases in the third generation. In third generation, 3GPP has released that in carrier aggregation is there. Carrier aggregation means suppose one 5 megahertz bandwidth will be there. In 5 megahertz 2-3 carriers, 5 megahertz carrier is used to club that one, aggregate and send it to the transport network. That aggregation, with that aggregation we used to get higher speeds. In even modulation techniques also changed in 3G. And in 3G, release 8 started using the, when we released the release 8, almost 4th generation, that is LTE technology also came up. In the world, so much people, those who are deployed, already deployed 3G, they have started using. But before releasing 8, after release of 8, that's LTE technology has came up. That is long-term evolution technology. That's WiMAX is another technology, but WiMAX is 16 point some version will be there. That version, but it is not highly populated, but LTE is the old accepted technology and populated technology, where this one LTE maximum speed we used to get 100 Mbps up to 1 Gbps in ideal condition. In 1 Gbps we will get with the carrier aggregation. Here the main bandwidth, the spectrum bandwidth is 20 megahertz. In that 20 megahertz we used to aggregate that one, 20 megahertz spectrum and another 20 megahertz spectrum. Like that 5 carriers can be aggregated and provide the for higher speeds. With that 1 Gbps you get hardly 10 MB maximum, they will say 100 Mbps in 4G technology, but hardly we are getting here 30 Mbps, 40 Mbps, very like that only we are getting. But in India we are getting 40, 30 Mbps because of the bandwidth constraints. Spectrum, our government is not allocated sufficient bandwidth to the service providers. Because of that, we are unable to get the maximum speeds. Here, 4G technology, that modulation technique has been changed. Earlier, we used to have GMSK, 8PSK, and QAM modulations. In third generation, we have QAM modulations technique. Here, totally OFDMA. Orthogonal frequency division multiplexing. With that radio resources we have effectively used, and multi antenna transmission, that is one of the best feature in the 4G. What is a multi antenna means? I will tell in the next slide. Here 4G evolution, major 3 changes we can see. What is that main three changes for driving the 4G technologies? Wider channels, that is 20 megahertz, even what is the and more antennas. More antennas means MIMO technology. It is the critical technology for 4G for allowing higher bandwidth and multi-stream transmission of data, like the means, and spatial means antennas can be altered, radiation patterns, we can say radiation patterns also can be altered using the MIMO technology. For the 4th generation MIMO technology, even our mobile handset used to have 2 antennas for receiving, 2 antennas for transmitting. When we receive when we have the multiple antennas, means 4G 2 antennas and like another 4 antennas will be in advanced LTE it will be there. But the technology concept is MIMO, where we could able to achieve the higher bandwidths using the multiple antennas in one form factor. We can embed 2 antennas, 3 antennas, 4 antennas in one form factor. We could able to spatial radiation patterns can be achieved from 5, 10, 20, 15, like because we have some signals where we can want to have a crowded area will be there, mostly where markets will be there, cinema halls will be there, malls will be there. In that area we could have a more coverage is required, more people will be there, density will be there. In such areas we have a multiple antennas we can install there. There another one is carrier aggregation. Carrier aggregation means 20 kilohertz one carrier, each carrier in 4G have 20 megahertz spectrum. Like that 5 megahertz carriers can be aggregated and delivered to on transport network. That total aggregation will comes to 100 megahertz. With 100 megahertz we can have 1 Gbps connectivity. But user experience is hardly, user experience bandwidth means when we are moving to the far to the tower, hardly we can we have to get maximum 10 Mbps speed. Here one more feature with the 4G technology is, earlier we could have FDD, duplexing technique, that is frequency division duplexing. Frequency division duplexing means, duplexing technologies, you might heard that one, duplexing technologies. What is frequency division duplexing? When a service provider like BSNL, we will get certain bandwidth, like 800 to 900 megahertz, certain bandwidth is allocated to ours. In that one, suppose we can have a like a 4G, we have a 20 megahertz one spectrum, another is 20 megahertz means another frequency band, another that is, we used to have downlink. Downlink means whatever we are receiving from tower to antenna to our mobile is a downlink. What we are sending from our mobile to, there is uplink. Here one frequency, like one frequency is allotted to downlink, another frequency is allotted to uplink. That is the earlier up to third generation we used to use the FDD duplexing, frequency division duplex. Here time division duplexing concept started in fourth generation. Fourth generation means any spectrum 20 megahertz, it will be divided into time slots, TTD. In that time slot, one time slot will be dynamic allotted to uplink, and one can be allotted to even more channel, more uplinks we can have, more downlinks we can have. With that one, what is the benefit of doing this TTD? Efficiently we can utilize, definitely. And one more thing, in practical way, like when we are using mobile, what kind of advantage we can get with the TTD? Time division duplexing with this one, generally what we will do in mobile, most of the time we will spend for downloading the data or video watching, that anything we are doing downloading only. For downloading we need more downlink, and uplink we are using, we are not at all, mostly we won't use that one, mostly hardly very less uplinks is required. In that way, when we can utilize the maximum whenever our needed, we can allot more number of downlinks, whenever is needed we can utilize uplink, one or two it is needed. Like that, in that spectral efficiency we can say, maximum spectrum efficiency we can achieve in the with the LTD TTD. How 4G network architecture will be there, how it will be connected? It is completely data network. It is complete. Earlier in 3G we used to have a circuit domain, packet domain. In fourth generation we have only data network. It is only data network. Here instead of RNC and BSC, BTS, we have only eNode B, and this is called mobile SIM. Here in fourth generation we have a eSIM also. eSIM provision is there. Physically we don't have to have a SIM in our mobile handset. eSIM, with the eSIM we can have with our handset we can have eSIM provision. With this one that what we have called as enhanced UTRAN, Unified Universal Radio Terrestrial Radio Access Network. This is called completely radio access network, became very sophisticated, and evolved packet core. This is core network is evolved packet network. We have very limited functional entities, functional elements. Here that is MME and serving gateway, PDN gateway, HSS, HLR, VLR, all are clubbed to HS, and PCF is policy control function will be there. Here actually this is the completely gateway network 4G. Here where all this mobility, like when we are moving from, suppose I am moving from here Kakinada to Rajahmundry, I am having a call, but I am my call is not disconnected throughout my journey, but call will keep on continuing. That will call handoff. That is mobility we can get with E node B, all are interconnected. Suppose this E node 1 and E node B, all these E nodes are connected for providing soft handoff for mobility. This here we can see this one, dotted thick line is there, dotted line is there. Here control panel, that is control elements, MME and HSS, this is be there, and PCF, this is control function, but establishing the connectivity, for establishing our having the access to our network. We used to this user part, it is connected to serving gateway, that is, and PDN is connected to only for accessing internet and everything. It is connected to IP network. For voice calls exclusively in 4th generation, we have a component called IMS. Most of you can remember that in 4G Reliance launched 4G in 2016. How he can provided a 1 year free service? Anybody remember that? Reliance completely freely they have provided the service for 1 year. How he can provide, how he could able to provide. Remaining Airtel also launched 4G, and Vodafone Idea also launched 4G, but they are not able to provide the free service, but Jio only provided the free service. How? That is there, everybody is doing for business only, not like that. But here, one technical concept is there. That is true, sir, that I am not denying that, but in that one, hidden secret, technical secret is there. Because of that, okay. That is, all calls are connected to internet only. Because 4th generation is nothing but internet, IP based communication only. Everything is data only, sir, data network only. Without, we don't have any other than that data network, only data network. 4th generation means everything with data only. Data based connectivity only, we have IP based communication. Why he has provided 4th generation means, for providing IMS server has to be deployed. IP multimedia system has to be deployed, and that is before deploying anything, it should be completely tested and accepted by the world. When they Jio launched the services, he doesn't have the IPMS subsystem exclusively for voice. That's the reason he is not able to provide, he is not charged for voice also. For providing, he completely provided free of cost. Sir, IMS, IP multimedia subsystem, it is in testing process. In LTE, nowadays all our mobiles is 4G mobile only. We are using all 4G. But here 4G for voice, we have a VoLT. In IP based, we have a SIP protocol. For VoIP, we used to have a SIP protocol. voice over IP. For in 4G network, we should have a VoLT services, providing VoLT services, you should have a old accepted IMS, IP multimedia subsystem. With that only we can provide voice calls. Before at the time of launching the 4G services by Jio, he has not have the IMS in his network. He has not the IMS. It is in testing process. After the completion of testing process, he started charging the customers. Till that time, he has given the free of service. But Airtel and remaining Vodafone Idea has not given the free of service, because even they also don't have the IMS, but they have not provided the free of service. Because whenever, if I am a Airtel customer, I am having the 4G phone with me, whenever I am in 4G network, I could able to, whenever I make a voice call, it will switch to third generation. From third generation equipment, voice call is going to establish. Like that, Airtel and remaining service providers are not able to provide at the free of cost. But marketing strategy, that is, he has done so much thing. That is the main technical reason for not providing free of service. But here, so VoLT, the fourth generation, I can see actually first generation, the latency is almost 600 milliseconds. We can feel that, like when we call ... it is going to connect. But in the second generation also, it is come down to 200 milliseconds latency. In third generation, the latency has come down to, with the compact design of this our system, come to 100 milliseconds. In fourth generation, it is almost come down to 10 milliseconds. Ideally, it is 10 milliseconds, but in our real-time applications, it is 20 milliseconds, 30 milliseconds, it is there. Devices, almost smartphones we have, IP-based communication, enabled social, that we can have nowadays, social media, YouTube channels, everybody started running their own YouTube channels and doing so many applications in 4G. Even in 4G, we can have our TV on our mobile, even Netflix, and we can have mobile. Everything that is streaming services, video services, all we are enjoying in fourth generation. Fifth generation in India recently in 2025, in 2025 our certain Airtel and Jio started this one. Main technology is new radio technology and millimeter wave frequency, that is 29 gigahertz, 39 gigahertz. We use that much huge spectrum we are having, and massive MIMO. Earlier in fourth generation, we have a 2x2 antenna or 4x4 antennas. Massive MIMO means when so many number of devices, number of antennas can be embedded in one form factor. It means so many antennas can be embedded in one form factor. So the almost more number of antennas for receiving, more number of antennas for transmitter. Have you observed this MIMO in our whenever you are seeing the towers? Have you noticed this practically in towers? Mobile towers, many of you have seen on the roadways or somewhere else. Where this MIMO, have you seen that? Antennas means big antenna, like this much length antenna, you used to people see that. But MIMO antennas have you seen? Pardon? MIMO antennas, this MIMO concept antennas, small antennas like wireless devices. We have Wi-Fi campus will be there. Here Wi-Fi campus is there, sir. For Wi-Fi campuses, they used to have one small router like that, like this also. Small antennas will be there. Small antennas for covering in this one coverage purpose. With this MIMO concept, robust radio path can be established. Means is one antenna, 2-3 antenna, when multiple antennas are there, it is receive, if one antenna receive less amount of some error, another antenna receives some good, when it is received and again it is combined to that one, that more accuracy we can get in that one. Speed is almost 10 Gbps up to we have 4G. In the fifth generation we have maximum, I can say this fifth generation started providing connecting our instead of our mobiles, we started connecting the devices also. This is the fifth generation network, like fifth generation radio part is completely replaced with new radio, that is next generation radio access network, that is again core network, separate core network and data network. Here we have not seen packet data network. Up to fourth generation we have a PDN packet data network. Here we have say in fifth generation we have a data network. Why we have said this as a data network? What is the difference between packet data network and data network? Whatever the any communication based on the IP we are doing, it is a packet data network. Any structured, unstructured data may be communicated with the help of data network. That is, fifth generation we could able to connect devices at the same time, machines. This millions of connections per kilometer square. That is the fifth generation concept. And again this massive MIMO. Another one is URLLC, ultra reliable low latency, almost 1 millisecond latency we could have in fifth generation network. Actually in the fifth generation architecture we could have reference point architecture, another one is service based architecture. A reference based architecture, here in fifth generation we used to call as a next generation node B, G node B. It is connected with different this AMF, access management function and session management function, that UDM is user depository and PCF, all these elements, these are network elements, all are connected, interconnected one another with certain protocols. Most of this network now in fifth generation deployment, so many companies, some like Airtel, BSNL, BSNL not just it is a testing process, all Airtel and Jio started providing this. This is service, actually service based architecture. Service based architecture is to provide in the so many companies and in the world deployed is a service based architecture. What is service based? Why it is called as a service based architecture? This one called as service based architecture. Why it is called as service based? Earlier we have not said that one. What is a service? Why we have called as a service based architecture? Suppose in service provider, BSNL is the service provider. I am providing different customers, different services what they needed, and service consumer will be there. Customer is a service consumer who is taking service from us. If you go to the bank, bank manager will provide the service to you. Whatever the financial services you need, manager will provide. At the same time, customer is a service consumer. He is taking the consumer. Here in fifth generation architecture, we have a service based architecture. Service based means elements, AMF, SMF, PCF, these are the services. Everything, every network element is a software based structure. Everything is a software program based. All are service provider. AMF is a one service provider. From other service provider, it will take its services. All are interconnected. This is the main architecture here. In this one we have a user plane. Here user plane is segregated and control plane is completely different, segregated. Here user plane, what are the customer want to have separate user connectivity, and control plane, here in fourth generation, all are the water. If you want to make a call, if you want to make access to the internet, he has to go to the MME function, that is dotted line connectivity, where we used to have a control functions. Everything for making a call and everything, it has to connect to first control function. From control, once the control function establishes, then user plane will come into the picture. In fifth generation, it is not like that. Control plane will not come, once a while it will come, and user plane, whenever you want to make a call, you would automatically from user plane protocol, and these are some network, important network elements in the fifth generation network. For suppose I want to user make a call, it will access management protocol. It is a radio access management. From that, it will authenticate and establish a call. It from here. All the in practical deployment of 5G services, user plane will be in our service area. Suppose in East Godavari district, one user plane will be there. All the data connected to this area is stored in UPF. For making calls directly, how the latency has been implemented, when for all authorized users, we are minimizing the intervention of control panel. Directly we are moving for accessing internet and making call. Directly we are taking the help of user plane. With this one, we are achieving maximum this latency. This is the fifth generation. Actually, International Telecom Union has given certain requirements, that is enhanced mobile broadband. Enhanced mobile broadband, that is EMPP, machine to machine type communication, that is millions of connections per kilometer square with this one technology, and one there is UR, ultra reliable low latency. With this one, latency is almost reduced to 1 milliseconds. Here maximum main functions in fifth generation is industry automation has taken place, and so many even healthcare system. Nowadays Gunturu, Kakinada, Tirupati is selected as a smart cities. Smart cities means everything, it will be connected, like traffic signals and even municipality services, all even water services what we are having, everything will be connected with even vehicle to vehicle communication, vehicle to infrastructure communication, vehicle to pedestrian. Suppose traffic, when we are in the real time, we can speak in fifth generation. Driverless cars are how it is driven. With this one, support of fifth generation only. These are the so many applications, VR, AR based communication we can establish in the fifth generation. Actually, in the fifth generation, how it will be established, everything with in different fifth generation. One of the beautiful element is network NSS, network slicing. Means for agriculture sector, separate network will be there. For network, separate with the separate networks for every different users. We have fifth generation network slicing. Sixth generation, it is needed, sir. Sixth generation real-time application is not started in the world, but the International Telecom Union has given certain requirements for what are the main backbone for this one is terahertz waves and network optimization, AI based networks. Earlier we have a data based communication, means huge data we are used to do with the help of. In fifth generation AI ML came in, but that much impact is not there. But in sixth generation AI based networks are established in this one, and advanced MIMOs, multiple antennas can be embedded in the device for seamless network communication, because seamless means latency is very less, 0.1 milliseconds to 1 milliseconds is the latency in this one. Means like many applications we can see virtual presence. If the person in the US, but he can virtually real time application, he can interact with the hours with like real time. The person, we will feel like a person is here. That is immerse communication we used to have in the sixth generation. But China in South Korea is doing this research, and China already has deployed the sixth generation, not in user based, satellite based sixth generation communication already working in China. China is more advanced in sixth generation. Actually, International Telecom Union in their paper, they have given this is the main requirements for sixth generation. That is EMBB, an immersive, that is fifth generation we have a enhanced mobile broadband connection. But here in sixth generation we have immerse communication. Means like with the advantage this edge computing and cloud computing, with cloud computing we can have a real time presence will be there with this one, and massive communication. Massive devices can be communicated, means number of devices per meter. Earlier for fifth generation we have a millions of connections per square kilometer, but hundreds, thousands of connections and devices per meter itself we can have that one, and high reliable low latency communication, that is maximum 0.1 milliseconds to, that is almost that is seamless communication we used to have that one. And new 3 features it is added: ubiquitous connectivity and integrated AI and communication, and integrated sensing and communication. Here flexible frequency sharing, that is cognitive radio for sensing, and DRR and MRSS, multi-radio spectrum sharing. These are the some 6G radio resourcing technologies. With that one, ubiquitous connectivity, they want to have connect all industrial ubiquitous mobile society, they want to establish with this 6G. 6G means all will be connected one another, nothing is left without unconnected, everything should be connected, and we should have all this will 6G communication will successful with the nowadays with this help of cloud computing, at the same time blockchain and artificial intelligence. With these are the main technologies for 6G generation for having a ubiquitous connectivity in our society. Anything, sir? with this one I can conclude this actually 6G is completely user centric and data centric, and entirely everything is centralized content. Means devices information, huge computing technologies is needed for the 6th generation that can be developed, and real time network optimization should be needed in the 6th generation. Thank you, sir. Any doubts?
Sir, what is the encryption in 6th generation?
Encryption means, madam, 6th generation encryption, encryption means, what is encryption? How we can provide, when 1-2 devices is there, security will be there. For that one only wireless communication security blockchain concept has started. In this one, encryption is very essential for 6th generation. Without encryption, we don't have privacy, and security also we don't have. That much is needed. For that one only, they are doing a lot of papers, presentations, research in that one, madam. But complete standard device, this much encryption protocol, it is not yet revealed. It is not completely deployed, but it is in under, mostly they are expecting 6th generation in 2030 in the world. But in India, when it will come, we don't know. But 5th generation mobile communication itself we don't have in India. Right now, we are not feeling that one. But in India, we are having only 4th generation is comfortably, we are having 4th generation mobile communication. 5th generation is not. Recently, Elon Musk also started mind-blowing communication. Starlink, that is 6G also not needed. He is directly making everything with satellite. His phone, he has separated for his Starlink communication, he has developed a separate mobile. It is not needed charging.
If he comes, BSNL
సార్ ఆడొక అందరం పోతాం సార్. అంటే ఇక్కడ ఏమవుతుందంటే ఎందుకు నేను చెప్తున్నానంటే మేడం, ఎన్క్రిప్షన్ అనే పాయింట్ మన దగ్గరికి వచ్చినప్పుడు అతను ఏం చేస్తాడంటే తన మెయిన్ న్యూరో లింక్ అండ్ న్యూరో చిప్స్ వచ్చిన తర్వాత ఈ టెక్నాలజీ వచ్చేసరికి మనకేమవుతుందంటే మనకి ప్రైవసీ అనేది ఉండదు. ఇంకా ప్రైవసీ అంటే మన ఇంట్లో మొబైల్ పెడతాము, మా ఇంట్లో ఏం జరుగుతుందో వాడు మనకు తెలియకుండా గ్రాప్ చేస్తాడు. ఇంకా వాడు సీక్రెసీ, ఇంకా ఎన్క్రిప్షన్, మనం ఎంత ఎన్క్రిప్షన్ పెట్టుకున్నా కనిపెడుతుంది వాడు కదా. అందుకనే యాక్చువల్లీ మనకేమవుతుందంటే ఇంత టెక్నాలజీ వచ్చినా కానీ మన ఒక్కొక్క కంట్రీకి ఒక్కొక్క టెక్నాలజీ కావాలి మన ఓన్గా అనే కాన్సెప్ట్ స్టార్ట్ అయ్యే బిఎస్ఎన్ఎల్లో 4th generation టెక్నాలజీని మనం ఓన్గా తయారు చేసుకోగలిగాం with the help of CDOT. CDOT is provided the software for complete 4th generation and 5th generation. Tejas network, that is a Tata backed network, that is they are developing the radio network. With the వీళ్ళ ద్వారా మనం ఏం చేస్తున్నామంటే ఎర్లియర్ మనకు చైనా వాళ్ళది, నోకియా వాళ్ళది, వీళ్ళ టెక్నాలజీస్ ఉపయోగించి మనం మొబైల్ టెక్నాలజీస్ వాడాం. దాంట్లోనే వీళ్ళు ఇప్పుడు ఇజ్రాయెల్ ఏం చేశారు, మీరు చాలామంది రాజకీయ నాయకులు వీళ్ళందరూ ఫోన్ ట్యాపింగ్ జరుగుతున్నాయి అంటున్నారు. ఇజ్రాయిల్ ఇస్ ద హైయెస్ట్ టెక్నికల్ అడ్వాన్స్డ్ కంట్రీ ఇన్ ఇండియా వరల్డ్. వాడి దగ్గర ఉన్న టెక్నాలజీ మన దగ్గర లేనే లేదు అసలు. వాడు ఫోన్ ట్యాప్ చేస్తున్నాడు. ఇప్పుడు వాడికి అవకాశం ఎందుకు ఇవ్వాలి? మన ఓన్ నెట్వర్క్ మనకుంటే మనం ఇంకొకటి మన దగ్గరికి రావాలంటే మనం బౌండరీలోనే చెక్ పెట్టచ్చు. అందుకని మన ఓన్ టెక్నాలజీ డెవలప్ అయింది. ఆల్మోస్ట్ ఇప్పుడు చాలామంది బిఎస్ఎన్ఎల్ తిడతారు, కాదని నేను అనను, ఎందుకంటే సర్వీస్ రాకపోతే ఎవరైనా అంటాము. కాకపోతే ఇప్పుడు కొంచెం ఇటువరకు ఉన్నంత 4th generationలో డేటా వరకు పక్కాగా వస్తుంది. బట్ మెయిన్ వాయిస్ కాల్స్లో కొంచెం కాల్ మధ్యలో హ్యాంగ్ అయిపోవడం, కాల్ మఫ్లింగ్ రావడం, అట్లా కొంచెం డ్రాప్ అవ్వడం జరుగుతుంది. అది కొంచెం మెయిన్ సెట్ బ్యాక్, అది కొంచెం వస్తుంది. మెయిన్ ఏంటంటే మనకి మెయిన్ టెక్నాలజీ, మనం మొబైల్ కమ్యూనికేషన్ ఎంత మాట్లాడుకున్నా వుడ్ ఉందనుకోండి సార్, మనం ఒక చెట్టు దగ్గరికి వెళ్ళామనుకోండి, మొబైల్ కమ్యూనికేషన్ ఎట్లా ఉంటుంది, చెట్టు తర్వాత బయటకు వస్తే ఎలా ఉంటుంది గమనించారు ఎప్పుడన్నా? చెట్టు దగ్గర ఉన్నప్పుడు మన మొబైల్ కమ్యూనికేషన్ ఎట్లా ఉంటుంది, చెట్టు దగ్గర నుంచి పక్కకు వచ్చినప్పుడు మన మొబైల్ కమ్యూనికేషన్ ఎలా ఉంటుంది సార్? అంతే. ఎందుకంటే గ్రీనరీ అనేది మెయిన్ అబ్జర్వ్ ఆఫ్ మొబైల్ అదే వేవ్స్ని అది అబ్జర్వ్ చేసేసుకుంటుంది, అది పక్కకి స్ప్రెడ్ చేయదు. అంటే మన గోడకి వెళ్తే వేవ్స్ మళ్ళీ బౌన్స్ అయ్యి బ్యాక్ వస్తాయి, బట్ చెట్టు దగ్గర రాదు, ఎందుకంటే అది అబ్జర్వ్ చేసేసుకుంటుంది. వుడ్ అనేది అబ్జర్వ్ చేసేసుకుంటుంది. థ్యాంక్ యూ వన్ అండ్ ఆల్. థ్యాంక్ యూ సార్.
Thank you very much, sir, for your detailed explanation on evaluation of wireless communication from 1G to 6G. Each generation technologies, everything you explained very clearly. So all these topics are very useful for the researchers, those who are working in this area. Thank you very much, sir. Thank you. I request convener and co-convener, please felicitate our resource person, Mr. B. Subbarao, sir.
థ్యాంక్ యూ. థ్యాంక్ యూ.
మీరు కూడా
థ్యాంక్ యూ సార్.
సార్ థ్యాంక్ యూ సార్.
థ్యాంక్ యూ సార్.
చాలా బాగా చెప్పారు సార్. మీకు ఇది అకాడమీల కంటే ఇండస్ట్రీ మీకు అంత అలవాటు